see that they line up and writing the line. The second one is using the intercepts, the x and y intercepts. We'll see how to get those intercepts and plot those points, connect the 2 points, and you have your line. The third method is what's called the slope-intercept method, using m, the slope, and b, the y-intercept, to be able to find what the line looks like. And the last one will be something called the point-slope method. Okay? And as we get to each one, I'll mention his name again, and we'll see how to do it. And then you'll have a battery of 4 methods when you're given an equation, how to graph the line. Again, this is another important skill that's needed in Algebra 2, something you did in Algebra 1, but now we're going to make it so that you are an expert at this. Okay, the first and probably the simplest method is given the equation of a line, plotting points. So let's go to the board and work through a typical problem. You're given an equation, so let's have an equation. How about y equals 3x minus 7? That's what my notes say, so let's go ahead and do that. Y equals 3x minus 7. And what I call this, and you may have seen this before, is making a roster of points. Remember, this is an equation that says, you tell me the x, I'll find the y, because x and y are related. In fact, as we'll see later on, more very specifically, y is called a function of x. All right, the roster of points, we have an x and we have a y. You say, well, that y looks different than that y. Well, I'm an equal opportunity y maker. All right, let's see. Let's put in some values for x, and then we will find out the values of y. Let's put in -3, -1, 0, 2, and 4. Why did I pick those points? Well, I like to have some negative values, not because I enjoy working with negatives, but because I want to have points on the left side of my graph. I want to plug in 0, because x is 0, remember that's the y-intercept, and some positive values, and I separate them out a bit. Well, let's see. How do I find the y values? All I do is replace the x with the number. If x is -3, 3 times -3 is -9, minus 7 is -16. Okay. Plug in -1. See, 3 times -1 is -3 minus 7 is -10. When x is 0, it's really simple. I don't care what the number is in front of the x. This could be 300 billion. 300 billion times 0 is still 0. So all we got to do is say, hey, when x is 0, y is -7. And that takes us back to remembering what we know about the y-intercept. The y-intercept, b, is the number out here. We have y equals mx plus b. And it's the value of y when x is 0. Well, the value of y when x is 0. We plug in 2. Let's see. We go 3 times 2 is 6 minus 7 is -1. We plug in 4. 3 times 4 is 12 minus 7 is 5. Is that correct? I hope so. You also might notice, for example, right here, as x went from 2 to 4, x increased by how much? Increased by 2. What did y do? Y also increased, but it increased by 6. When x changed by 2, y changed by 6. 6 over 2 is 3. Notice we're back. Our slope is 3. Now what do? We plot the points. How do you plot points? Well, again, just as a review for those of you who may have been asleep that week in Algebra 1, we go over and say, okay, -3, -16. On our graph paper, we'd find where x is -3. We go down where y is -16 and make a point. And in fact, the first visual in this lesson shows us the points that we've just obtained in our roster. So let's take a look at that visual. By the way, let me mention something about this visual. If you're looking at the points and the ordered pairs, you say, wait, that's not right. I mean, those boxes are strange. No, what it is that this particular graph we've done, each box, both in the x and y direction, stands for 2. All right, so we can find way down at the bottom at the left, we have -3, -16. We have the point negative 1, negative 10, 0, negative 7, 2, negative 1, 4, negative 5. We've plotted those points, and now what do we do? Well, we don't draw the line. The first thing we should do is say, hey, are they lined up? What's the best way to find out if they're lined up? Take a ruler or a straight edge and see if all the points fall on a line. If they do, as they did here, draw the line. Notice the line really goes beyond the points. In other words, in effect, that line goes on forever and ever. So we don't just necessarily draw it from negative 3, negative 16 up to 4, 5. We also extend it a bit. And in some classes or some teachers might expect you to put a little arrowhead at the end of each, just like we did when we did those inequalities in the number line, to show this line goes on forever and ever. Okay? Let's take a look at the next visual. What's different about this equation that we want to graph? What's different about this equation is that it's not given in mx plus b form. 2x plus 3y equals 6. Okay? What happens here, if we want to do it and we want to go ahead and make a roster of points, it is almost essential, if we want to make it easy for ourselves, to get the equation in y equals mx plus b form. So what did I do? Well, we want to get rid of that 2x. We subtract 2x. We get 3y equals minus 2x plus 6. We divide by 3. And we get the equation that's shown in the second line in the visual. Y equals negative 2/3 x plus 2. Then I made a roster of points. Let me ask you another question. Look at the values of x. How come I chose negative 6, negative 3, 0, 3, and 6? I actually chose those numbers for a very specific reason. The reason is, you recall, I don't like working with fractions. The slope that I multiply x by is negative 2/3. By picking numbers that are multiples of 3, when I multiply, for example, negative 6 by negative 2/3, I will get a whole number, in this case positive 4. When I add 2, I get 6. And as you can see in the roster, the point is negative 6, 6. I completed the roster. I would plot those points on a graph. Take a straight edge, make sure they line up. Once they line up, draw the line. And I have my line for the equation 2x plus 3y equals 6. Okay. There are other methods in terms of finding the being able to graph the line other than using a roster of points. Some people get bored with this. And you know what happens when you get bored? You make careless errors. And if you make a careless error, you get wrong points, you might get the wrong line. So, as an alternative, let's look at the next method, which is using intercepts. And let's take a look at the next visual, which is y equals 3x minus 12. Let's go back to our definition of what the x and y-intercept are. The x-intercept is the x value when y is 0. The y-intercept is the y value when x is 0. So the y-intercept, I replace x with 0, y equals negative 12. Notice written as an ordered pair, 0, negative 12. Y is negative 12 when x is 0. To find the x-intercept, I replace the y with 0. When I get 0 equals 3x minus 12, I solve for x, and I get 4. Notice the ordered pair is 4, comma 0. X is 4 when y is 0. I plot those 2 points as indicated on the visual and connect them. Now, the one thing that is, I don't want to say bad, but the one thing that can make room for error with this method is you only have 2 points. The nice thing about the roster method is you have 3, 4, 5 points, and if one of those points is plotted erroneously, you'll know because the points will not line up. Here, when you plot the 2 points, if you make a mistake with one or both points, you will not know it because 2 points always line up. So you got to be very careful. But this is certainly a very quick way of being able to graph a line by plugging in 0 for x and solving for y, plugging in 0 for y and solving for x, plotting those 2 intercepts, the x and y intercept, and connecting them up. So let's take a look at the next problem. The next problem is, again, not written in mx plus b form. 3x plus 6y equals 24. In effect, this method, which was one we had to change to y equals mx plus b in the previous kind of problems is great for the x and y-intercept. As seen in the visual, all we do is to get the y-intercept, plug in x is 0. We get 6y equals 24, y equals 4. So 0, 4 is the y-intercept. Then we take the same equation, 3x plus 6y equals 24, and replace the y with 0. Solve for x to get the x-intercept, 8, 0. Plot the 2 points, 0, 4 and 8, 0, and draw our line. You'll notice on some of these problems we're doing here, I haven't shown you the line. Why? Because I expect you to do it and then convince yourself that's the right line. And how could you do that? Well, remember, we have already seen 2 methods. We're going to see 2 more methods. Try another method for the same equation. If you get the same line, then you know you're right. I would hardly think that if you did the same problem 2 different ways and got the same answer, they'd both be wrong answers. Okay. The next method is called the slope-intercept method. Slope-intercept method is uses the slope and intercept, which is, I'm sure you find very strange. No, you shouldn't. Of course, the slope-intercept method has to use the slope-intercept. Obviously, we need the equation in y equals mx